Well, hello, welcome back. We are going to be doing the final task of engineering design. And this one is a doozy. A lot of work went into this. I want to show you everything that was done so you can really understand the process. And I want to talk a little bit about what documentation we want from you for this document or for this project. So let's get right into it. So the first thing we're going to do is we're going to open up our engineering design. Already got it. Here it is. So I'm going to scroll down to the last day or the last piece here. And as you can see, there would be 3 days for this plan because it's going to take a lot of work there to put this together. So you're going to be opening the design project, railroad crossing system task. This is your final project, and the railroad crossing is usually fitted. If you've ever, I don't know if you've ever crossed a crossing where a railroad crossing is, but you always have some sort of warning system, most of them, so you don't get hit by a train. Seems like a smart thing. Most of them automatically activate somewhere down the track. There's a sensor, and when that weight is put on that sensor, it knows that in a certain amount of time that train's going to come. So then the barriers come down, they stop the vehicles from driving through. When the train's gone, it comes up. So what you're going to do is you're going to design and build a model of a railroad crossing with an active warning system and gates and lights and barriers. And you're going to need to complete all that information listed in the rubric as well. I'll show you all that information. Then there's a quiz once you finish. You'll finish the quiz, and then you'll be able to move on and get it all turned in. So let's kind of look first at the course. And I'm going to open up the design project, and here it is. So let's kind of hear the introduction.
Lab work, design project, a railroad crossing system. Railroad crossings are designed to allow cars and people to safely cross a railroad intersection. A railroad crossing is usually fitted with an active warning system that automatically activates when a train is approaching. Design and build a model of a railroad crossing with an active warning system that includes gates, lights, and barriers. Use the VJC control software to write a program for your design. Use the help sheets for assistance.
All right, so here's the brief. Here's the real simple stuff to know. You're going to design and build a model of the system. You're going to have a push button. When you push it, it triggers the trains coming, and then what will happen is the two set of gates will come down, and then they will sit there with warning lights and sounds. And then after a certain time has passed, or by creating a second button, which is what I did, they'll go back up, and people could walk by, cars could go through, whatever. So through this process, we've been studying the design process, thinking about flashlights and looking at how a flashlight could be used throughout the design. This final step is going to be documenting all the information. Now there is this nice little link here that shows like what it is that you're supposed to document through all these different things. So really you first start out with trying to figure out what the problem is, then define the requirements. This is all going to be done with one document that you guys already know, which is the design brief. You then need to brainstorm solutions, come up with multiple ideas of how you could do that. The example they use here is for a system to heat up water. Then you evaluate the solution by doing a design brief. We'll have a document for that. While you're building, you should be thinking about all the work that you're doing and how you monitor the process, how you document the work that you've been doing day to day. Those would be through reflections, daily reflections, which we've done before. And then you also want to make sure you show that final design as a final sketch. So you'd complete that final orthographic sketch with an isometric design that shows the 3D model. Once you think you got it done, don't forget you got to test and evaluate to make sure you can see that your system works well. And then eventually it's communicate the results, giving a full detailed report, or turning in the documentation is what we're going to do. So that's what you're going to be expected to do through this whole process. Now, let me show you the documentation that's set up here. So through here, I said there's the rubric. So let me go ahead and open up the rubric. Where is it? It's at the end, isn't it? Of course, it's always the last document. So obviously, you've seen this rubric before. This is the same expectations we have, and we're going to expect you to kind of tell us, hey, after this project is done, and you are ready to turn everything in, what do you think you are? Are you at an advanced level of knowing this? Are you proficient? Are you emerging, developing? And your documentation is going to be your proof if you know it. And then obviously the design that I'm going to show you here in just a little bit. These are all the things that kind of show you or show us, do you really understand what you're doing? So here are some of the criteria that we're going to be looking for. All your documentation is done properly. That's going to be important. And then the build. So these are the things that they talked about having included. And then don't forget, there's also the programming, which we'll be doing right up here in a little while. So to kind of help you stay organized, we have our checkoff sheet. Read over the expectations. We did that already. Complete the design brief. I'm going to show you that in just a second. With this project, we want you to complete the design brief. We want you to fill in some of the blanks to show us that you understand how to fill that design brief. Some of it's filled in for you, but not everything. Then you got to brainstorm. So this is where you start putting information in your notebook. Brainstorm with 3 different sketch ideas. Again, just thumbnail sketches, a couple little notes included in it, a drawing so people can see what your thoughts are. Just like we were showing you here a little bit ago with this one, when you're looking at the drawings and stuff, you got to have multiple different ideas. Have some of these little notes, these annotations that show you what these different things do. Flip lid, okay, I know what that does. It flips up and you're able to have the water come out. This one shows a little window. This one has a window. This one doesn't. So having those things to be able to show is what you would be putting in your notes. Once you have those brainstormed ideas, then you have to start thinking about how you're going to narrow those ideas down with the decision matrix. Again, stuff that we've looked at through the notes and presentations on here already. This is now taking all the information you've learned in your notes and you're practicing, and now you're applying it to this final project. Then as you're building, you keep notes. That's our reflections. And you keep reflections on the building process. And then at the end, you're going to need to complete a final sketch. Using our sketch form again, creating our top, our front, our right view, and then your isometric. So all 4 of those. And they're going to need to share your information with a final write-up. So the final write-up is going to include the following things, which have to go into your notebook as well. Describe how you met the requirements or you didn't meet the requirements. So all the requirements that are listed up here, how did you meet them or how didn't you meet them? What did you struggle with? Okay. You're also going to want to include in your final write-up any suggestions for improvements that you may want to do if you had the chance or you want to go back and complete this later. Or someone else is going to complete it based on the documentation they see from your work. And then explain how you went about the programming as well. So there's the whole programming side, the coding side. I'd like to know how that went for you as well. So it's not too much, paragraph at most. And then finally, you got to turn everything in. So you got to make sure in your notebook you have your design brief, decision matrix, the daily reflections, your final sketch, the write-up, and then obviously the programming form, which I'll show you in a little bit as well. So all of these are links to getting stuff. So through the process, as I would work through it, or as I did work through it, here is the design brief. You're working for the Off the Rails Railroad Company. Get it? It's not good, but we're going to be safe. You'd put your name and any group members down there. Your problem statement. This is where you set up what the issue is and what you're trying to solve. Now, hint, hint for this one, that information is in here. Okay, one of these 3 paragraphs might be the one that actually has what it is that we're looking for as an actual problem statement. The design statement is very simple, very straightforward. You're going to research, design, build, and test what? To do what? Okay, again, this may be helpful by having some information here already to help you build that. Now, these things become more of a criteria, some things to think about, but that information is there for you as well. So here's the criteria, the things you need to physically have, and then what it is that you're actually going to turn in when you're done. Well, your engineering notebook, showing all the documentation things we looked at, including the sheet, the design brief. You have to have your prototype built. Got to be able to see that. Got to have the programming written, and then the rubric. And again, as I'm demonstrating this for you today, you'll see most of my stuff, but I don't fill all these in because I don't want to give away all the work you have to do. The next one we have here is the decision matrix. So we're thinking about the railroad crossing. You have to come up with 3 different designs, three different designs of how you could create a railroad crossing. This is where having the kit with you is good, so you can see all the parts, you can see what things you can choose, how you can assemble these things, all that stuff. Then you have to score them. Now, these are the things you have to think about. Is it easy to use? Does it look like it's going to function properly? Does the appearance look real? Does it look like something that's going to make people go, hey, you can't cross this? Maintenance, is everything put together properly in your designs? Have you thought about everything in your sketch that that could be put together in the right way? Ergonomics, how does it look? Is it appealing? Is it going to be distracting? Does your sketch show this stuff? Is it programmable? Did you put stuff in there that you know you're not going to be able to program because you're going to have something that goes up and then to the left or right, and it's going to move in different ways that you know you can't build? Are you including those safety things, the warning lights and the sounds in your sketches? And is it function with consistency? Do you think your sketch of what you want to build could be done over and over and over and over without any errors? Now, until you build it, you're not going to know. But these are just things you want to think about based on those sketches you created. And then you're going to put a score in here. So it's either a 4-3-2-1 or a 2-1. So basically, the one that has the highest score is the one that you're going to accept. Now, I did put two down here. I put two empty ones because I didn't know if you would think you would want to have some of your own things that you want to think about. That's always something I'm interested in seeing as well. If you want to come up with your own stuff to add there. Once you look at which one had the highest score, tell us the design and explain why with detail. Don't just say design 3 because it had the highest score. Tell us what about that one scored higher than the others. What were some of those pieces that stuck out over the other ones, and that's why you're going to try it. So that would be the decision matrix. So once you have that done, you've kind of gotten through the first 4 pieces here of the checkoff sheet. Now gets the fun part where you're going to build and build. So you're going to be taking your notes. You're going to be keeping track of what you're doing each day. You're going to have to work on the final sketch then when you get to that point of the final sketch. This is once you've built your entire thing. So I'm going to show you mine. Mine would be in this final sketch. I'd have my 3D drawing here, my top, front, and right. And what also do you want to put in these? You want to put dimensions. So we should know about how wide it is, how long it is, how tall it is as the entire piece. Because these are just rough drawings of like the entire view from the top, the front, and the right. We don't need all the little detail and minutia of all the measurements of all the little things. It's just the overall, how big of a footprint is this thing going to take up? So after you have that all done, because you built it and you kept track, and then you do the write-up. And then one of the last things you're going to want to do is a programming form. So I'm going to show you here. This is the programming form filled out. Normally it'd be an empty sheet and then you're going to fill these things in, but this is my program. So I took screenshots and I just put them in the box. It took several screenshots to show all my code. And that's what you're going to have to do with that. And then the last thing you have to put into your document is sharing how you connected everything. So find the controller connections. So what things went into what connector and what port. And I'll show you mine in a little while so you can see the demonstration of how this all works, because you would have been doing all this through the whole process and I'm rushing it through to kind of show you. Did all the work, this is what the final product is going to look like. So now that I've kind of looked at, I've gotten to everything here. I've got it finished. All this stuff is going to be located in my notebook. I'm going to be turning in my notebook, including this rubric, and me putting down as a student what I think my grade is, what I deserve. And again, it could be different if you're in a group, what grade you think you deserve compared to the others. Maybe you think you deserve a higher grade. Well, why is it that you think you deserve a higher grade over the rest of the group? Probably had better documentation. You took more of a role in the group work, and we will take that into consideration when grading, because we know not everyone in the group works at the same level. Maybe you did. Maybe you all think you deserve the equal share, but sometimes people think they deserve more. We'll judge that later, but I want to hear your thoughts, and usually I take your thoughts into consideration. So let's get into what the final project actually looks like based on the work that was done. Okay, so it's time to actually see the work that's completed. You'll see that's the rubric that we followed. So let's take a look. First thing I want to do is I'm going to go over here to the coding, and I want to show you what I came up with my coding. and let's talk about it. So shrink me down, move me over. I guess I didn't need to shrink down. I can go up. So I put everything into an infinite loop. And the reason why it's an infinite loop is this is something that hopefully can run repetitively over and over and over with no issues. Now, the first thing I want to have happen is I want to make sure I have a green light in port 1. I want the green light to go on and stay on because I want to make sure that people know it's clear to cross. And actually, while I'm doing this, I've already downloaded it. So I'm turning it on so the green light's showing when we go to it. I'm going to have a switch, an input output 0. When I push that switch, what's going to happen is it's going to trigger an alarm when it's on, when it's at 1. And that alarm is going to go on for 4 seconds at that sound. What's going to happen then is I'm going to turn on the other warning lights, and the green light's going to go off because it's not safe. But as long as the warning lights are going off, that's going to alert them. I'm going to have 2 motors. Both of them are going to start running negative 100. That's because negative is going down. So at negative 100 for 3.5 seconds, it's going to go down, and then it'll be at 0. So then that means it's going to stop moving. The motor's shut off. And it's going to stay down because trains are crossing. Well, actually, it wouldn't go this way; just go one way. Okay. Well, it could be. You could have 2 going opposite directions if you're at a main junction. But once it's clear, then the second second switch is going to be pushed, and when that's turned on, a different sound is going to go on for a shorter amount of time. Warning lights come on. Safety light is off until it's cleared. This time, you'll see that it's going to go at 100 speed in a positive direction. So that means that the barriers are going to go up the opposite direction and then stop. Then it will delay and the lights will go on and everything will move on. So that's how everything's going to work in the background. I'm just testing it real quick. Make sure it works. There's the delay. There's the barriers going down. And then after the train's passed, I'll push the barrier up. Now the barriers go out of the way and they are back to where they need to be. And now the process will flow again because everything is going to work the way it's supposed to. So let's see if everything works the way it needs to. It's time for me to move my camera so we can see that this code is going to work properly. Okay, so actually we'll keep the code up. You'll see the camera. Let's go ahead and move this over for you. So here is my system, all done, all completed, working the way it needs to. We'll take a little walk around with this. First, here's the brick. And you can see all the cords are kind of hooked into the right spots, and that's why we have that programming form to keep track of it. Here's the 2 motors. Little blurry camera. There's all the functionings, button or switch and switch, and those are the lights. Here we'll see the first setup. Now in the supporting details, I used how to make a gearbox. So I used the same gearbox. Actually, they're both left gearboxes to help set that up. But then I had to program or design it just a little differently so I could put this gate bar on there. So it's a little different than the program. I just used it kind of make me think. I had to stack these and be creative on how I connected them all so they're not all moving all over the place. And actually, these pieces are barriers that I had in here, but I took them off just to see if it's going to hold on its own without them needing to be there. So we'll see. Here's the tower with the light systems. You can see that right now, green is on. So green is good. That means it's safe to pass. And as you can see, it's kind of an open road here. It's definitely safe to pass and go through as the road is kind of open. I have a switch. That's actually my second switch. That's my first switch to get everything going. Then on the other side over here, we have another motor system, and this is the second. This is the This is the second barrier on the far end. And I'm just going to set that down for a second. Make sure it's all tight. Okay. All right, so we're going to see if this thing works the proper way that the programming is set. So right now I've turned it on. I have a complete white page, so I know it's turned on. Green light is going. When I push this button, we should hear the alarm go off and then the gates go down, and then it's going to stay there until I push this switch or button. And when it's turned on, so when it's in the one position, it's going to go back to where we're at. And it should happen repetitively. So here we go, crossing my fingers that it works. Cross my fingers. Hear the siren or hear the alarm. You see the lights go on and the green goes off. Okay, so they're down. The one is a little off, but no big deal. When I push this back on, oops. When I push the switch on, it should work. Oh, come on, you worked like a million times right before this. This is how everything goes. This is okay. You get to see my process of working through things. Looks like my motor came off, so I got to get that back on. Okay, there we go. Now it comes back up, and it's back in its spot. So I think that because I moved these little pieces here, now it's all kind of messed up. But now my test is to see, will it function the same again as we try to do this repetitively. So I'll have this, maybe I'll hold it at this angle so we can see it. Green light's on. And then they go down to their spot, so the barrier is blocked. Okay, and we go back up. Oops. Problem with having one hand using the camera, we can't see it. All right, let's see if I can hold it at a different angle, and this will be able to see it all better this time. So it worked all the same time, twice. Push the button again. Siren goes off. Lights change. Okay, everything's put into place. Now I'm going to push the button again, so everything's working repetitively. And we watch. I'll show you this one. This one goes back up, so we can see that one's in place. And last thing, green light is back on. So now everyone can pass. So that means our app worked properly. Or not our app, our prototype worked properly. We've created a crossing system that's also repetitive. It's working over and over and over. So that's great stuff. So it would have been great for you to build them. Maybe you can still build them later, but this is at least the process so we can see how everything went. So now at this point, all we have to do is just double check. Did we have everything we needed to in the documentation? Did we have everything that our form said we needed to? And I believe I've walked through everything that you needed to see as far as documentation. So everything is there. All the documents are shown in the rubric. Now you'd have to take the quiz after you have your documentation, and then that ends basically the work project part and all the quizzes for this. All that's left now is to take the test. Open notes, use the stuff that we learned in the presentations and all that stuff. Take your test and do your best. That's it. We'll see you next time we have another unit here in LJ Create. Thanks for walking through all these videos with me. It was fun making them and fun making the kits too. So